Well, hello, everybody, and welcome to our August 2025 Akka.net Community Stand-Up. My name is Aaron Standard, and I'm joined here by my colleague, Gregorius Sodharmo.
Hello.
Gregorius, how are you doing today?
Oh, pretty good. And how are you?
Just working on trying to get a million things done all at once. We're trying to get an Akka.Streams.Kafka YouTube video out in the next day or two, which basically we're going to talk a little bit about that during the releases today, but that's one of the most underrated parts of Akka.net by a long shot. So that's something that we definitely want to try to get more people in the habit of using. So we're going to talk a bit about that. And then we've got a couple of other things that we're working on around new Phobos releases and all sorts of other stuff. All right. Well, I guess we should go ahead and just dive right in and start talking a little bit about some of our more recent Akka.net releases. So we didn't have a community stand-up back in July. We basically were kind of in the middle of doing a whole bunch of stuff, but we have a whole bunch of releases that are shaping up right now or ones that we've recently done. And we've got some exciting stuff coming down the pipeline. Namely, the big thing we're going to try to get done relatively soon here is flipping over the development branch on Akka.net to become Akka.net 1.6, which means we're basically out of like bug fixing mode at this point, and we're on to like feature development and trying to make pretty significant changes to Akka.net. So we're real excited about that. It's not for any lack of trying on our part. It's just that we've had a fairly high amount of support work that we've done over most of the year. And then on top of that, I've personally been busy. If any of you follow me on Twitter, I've been pretty busy re-architecting SDK bin. That's been my big project since, I guess, early May, probably. So we have been working feverishly on that. But we'll go ahead and start by talking a bit about Akka.net. All right. So we've had several Akka.net releases, and we're getting ready to do another one today, probably, since our June meetup. So the most recent one we did was 1.544. And Gregorius, correct me if I'm wrong, this issue you fixed here was actually a memory leak in Akka.Persistence, was it not?
Yes, it is.
Yeah, this was a memory leak with Akka.Persistence where basically the timer would leak, if I'm not mistaken. So we got that fixed in 1.544, pretty small release. 1.545, which was a much bigger release, and you were all over the place on here, Gregorius. So why don't we start by talking a bit about these two sharding issues first? Let's dive into those real quick. So this one with the sharding consumer controller, this is from Cluster.Sharding.Delivery, correct? And
Yes.
yeah, here we go. So let's see. What was the basic gist of this issue again?
Been a while. Let me look at the issue.
Yeah. If I recall, the issue here was that when we had remember entities turned on, the shard, yeah, here we go. When remember entities is turned on, and I guess it could happen without remember entities turned on too, but basically, the sharding consumer controller would stop itself without waiting for its death watch children, causing basically a whole bunch of death watch messages to dead letter. I think this basically caused leaking inside the delivery system, is what this caused here.
Yeah.
So we fixed that. The really big fix was this issue here, which I think it was Jason Shave who reported it. See if I can pull. Well, he reported this in Discord, but I actually filed the GitHub issue. This was kind of an interesting bug in that what happens when an unstoppable force meets an immovable object, which was in the event that you had a botched configuration. Let's say Akka.Persistence, for instance, was like misconfigured inside your application. And you have a bunch of remembered entities who start up all at once, and then they launch their actors. And the actors can't launch successfully. They keep killing themselves over and over again. Essentially, the supervision strategy is reporting back that these actors can't start correctly. Well, what remember entities would do is just keep brute force trying over and over and over and over again to keep starting these actors, where you'd get things like 100,000 actor restarts per minute in a busy system. And the real issue here was basically that the remember entity system and the supervision system essentially had different points of view on what should be happening to these entity actors. And really, the supervision strategy should be the winner, where if it says this actor needs to die because this actor is truly not able to start up or recover, the remember entity system should respect that and stop trying to restart that actor. And that was, if I recall, that was the design decision that you and I came to, Gregorius, and you're the one who actually had the fix here.
Yep. That was
And
correct.
as part of that, I think part of the fix here, if we go down to cluster sharding settings, it is now possible to specify the supervision strategy that the shard uses to supervise the entity actors. So if you have something specific you want to keep a lookout for, and you want to make sure that you want to basically make sure those entity actors respect that, you can actually go ahead and explicitly customize the supervision strategy now. We weren't using anything other than the default supervision strategy before, so this really is not like a breaking behavioral change or anything. The only difference is that we basically wrap the supervision strategy inside like another little messaging layer that tells the shard, this actor got hard killed by the supervision strategy. Please stop trying to remember it. If I recall correctly, anyway. So this is a pretty important stability fix for people who are using remember entities. You'll get some value out of that. Let's see. A couple other big changes of 1.545. So this one, a third-party contributor submitted that. Thank you very much. Submitted it a year ago. It took us a year to get around to repacing this and getting it to work. But the basic gist of this was that when you're using the untyped ask, you would not get a status.failure message back if you were basically, well, actually, I take that back. If you were doing ask.object and you got a failure back, it would just return that like a normal value rather than throwing a status.failure. And this is a little bit of a breaking behavioral change in the sense that we fixed a long-standing bug. But that's all corrected now. And that's been incorporated back into the code base. Man, Dependabot has been going nuts. Referencing this pull request everywhere. Jeez. I only just noticed that it's been doing this. Well, I don't. There's a reason why I don't have GitHub notifications turned on. But yeah, this was another important fix that you contributed, Gregorius. Now, if I recall correctly, the story behind this. So we've had one customer that's reported a couple of bugs. They're running on AWS Gravitron instances, which use an ARM64 based architecture. And I don't expect most people to pay attention to the sort of the particulars of how like memory fencing and memory safety works across different processor architectures. But long story short, ARM64 does not have a lot of the niceties that x64 and AMD 64 both have. For being able to make sure that things can be accessed safely. So this was a race condition that was causing, I believe it was Akka management not to start correctly, where basically we do this thing called inject top level fallback. So when you install a plugin like what would be a good example? If you install a plugin like Akka.Persistence or Akka.Streams, for instance, which kind of is like a late binding, we don't really activate that plugin until the first time someone uses it. We need to be able to inject the default configuration into the Hocon chain to make sure that the default values for that plugin are available in the environment somewhere. Well, the problem was that the way we were doing it, it was just a good old mutable field right here that we would just mutate on the fly. And that would sometimes also fail on x64. This is straight up a race condition. Like this was not designed right even for x64 architectures, but this would fail constantly for ARM64 architectures. So we fenced that off inside an atomic reference, so that can't happen anymore. So that's all been fixed. And then Akka.NET 1.546 was a pretty minor fix. We basically stopped hard coding the DNS provider that Akka.io.dns uses. And this is to set us up for a feature that I'm hoping we can ship soon. I'm planning on taking a look at that PR again, Gregorius, which is we're adding DNS-based discovery to Akka management, which should allow you to use basically DNS records. I think it mostly uses serve records, SERV, for doing some of the discovery. I haven't quite. He documented. It was a contributor who wrote that, Pavel, but that's more or less my understanding. Anyway, this is a necessary fix in order to facilitate that. So these are all kind of the big Akka.NET releases that we've done so far. We shipped new versions of Petabridge.command and Akka.Persistence SQL that all support all this stuff. The other more recent fixes, we did 2 yesterday. Akka.Streams.Kafka, we did a release here. We basically fixed a couple of race conditions in various areas of where we interact with the Kafka client in ways that aren't fully supported by the native Kafka driver. So that's been fixed. So namely, if you're using the plain partition manual offset source, this source basically allows you to subscribe to topics and automatically be assigned to partitions, but allows you to manually specify which offset you want to use in here. Anyway, so we fixed that. So now the seeking to custom offsets actually works correctly. And then we fixed a couple of shutdown issues when basically you could create an infinite loop when you were trying to shut down a partition. And that's been fixed as well. So those are just kind of stability fixes mostly. And then we also shipped a new version of Phobos yesterday. This is our open telemetry instrumentation. Oh my gosh, Pavel's here. There you are. Pavel is the guy working on the Akka Management DNS Discovery plugin, which we're about to talk about in just a second. But yeah, he's been having a tough time sourcing a Windows machine to continue testing that pull request. No worries, Pavel. We're going to be able to help you out with that here, I think, in the next couple of days or so. So I'll give you an assist. And thanks for your contributions. We appreciate it. So Phobos is our commercial plugin for doing like open telemetry instrumentation inside Akka.NET. Tracing in particular is the really big thing that Phobos handles. It turns out we broke probably last year sometime trace continuity when users are stashing messages. That's been fixed in Phobos 2.9. Highly recommend that you upgrade. And then this brings us to our future Akka.NET plans. We've got, I guess, the Akka management stuff isn't on here, but we should still talk about that. One of the things that we shipped is Akka hosting 1.547 beta 1. There's what this is all about. So I haven't even had a chance to really use this myself yet and validate it, but that's what we're going to do. The basic gist of this is that we have completely rewritten the Akka HealthChecks library, and it is now directly incorporated into the base Akka hosting NuGet package. I outlined here what the motivation was for doing this. I think the basic issue, and Gregorius, feel free to chime in here since I think you've had to do the lion's share of bug fixing around this stuff. Our original HealthChecks implementations were way too aggressive in terms of like how quickly they could turn a cluster from healthy to unhealthy. Would you say that's true, Gregorius?
Oh, yeah.
Yeah. So basically it operated on a hair trigger, and that resulted in wild swings of availability, which kind of made the plugin dangerous, to be honest. The new design approaches things much more carefully and tries to use fewer, more meaningful health checks. Other issue was the old HealthChecks library was very cantankerous to configure. You had to configure it like 3 different places, install several different NuGet packages, etc. This was an original design error I made when I originally created the library. One is I wanted to decompose it into a bunch of smaller parts, so you didn't have to pull in all the parts of Akka.NET you didn't necessarily need. We basically have kind of like disavowed that, and now it's like this is all just built into Akka hosting, the core library now, with the exception of I think the cluster health checks are all part of the Akka.Cluster hosting package. And it all just works. There's only a single API call you need in order to do that. And then on top of that, writing a custom health check was very difficult to do with the Akka health check library. We basically reversed all those decisions here, and we include some examples. So basically, if you want to go and run this example project out of the Akka hosting basically repository, you can kind of get an example for how it works. But this is what the health status information looks like running on the default HealthZ endpoint. We've also made it very easy to write a custom health check now. You can just call this with health check method, give it a name, and then just write in an async function that takes in the actor system, the actor registry, and a cancellation token. So all of our health checks that are incorporated directly into Akka hosting basically use an implementation of this method in order to do that. So it's designed to be very, very simple to implement your own health checks now. This should be a tremendous productivity and quality of life improvement over the old library, which will probably deprecate and encourage people to move. We just haven't marked this as stable yet because we have not had a chance to actually use it in one of our applications. We're planning on incorporating it into SDK bin within the next, hopefully, couple of weeks. I just haven't had a chance to actually do that work just yet, but we're going to try to work this into there, see how well it goes. We're going to be using this in production for our live health checks, and we'll, if we find that there's issues with it, we'll go ahead and keep tinkering with the library as needed. But that's a big improvement there. I want to go ahead and pull up, since I left this off of the agenda, but I didn't mean to do that. I wanted to pull up Pavel's Akka.Discovery.DNS plugin, which is a massive contribution that he's been working on. So I'll go ahead and include a link to that here. The basic idea behind this is to include the ability to basically, issue I guess it's an SRV query to find A quadruple A records from the default resolver for being able to perform DNS-based discovery. He's got a full sample of how this works. Gregorius and I have both reviewed it a couple of times. The only issue we're running into right now is that the sample doesn't really run well on Windows, which is something that we kind of need to think through before we ship it. So we will help Pavel do that. But I'm very excited about doing this because right now, most of our discovery implementations usually require something like a database or a Kubernetes cluster. Having something that uses bare bones sort of internet infrastructure would be a really great addition to the family. So we're very excited about that. Other couple of things that we have on our to-do list right now, or things that we're about to ship. Let me go ahead and pull up some of the work we've been doing on the Akka.NET TestKit. So we're about to do an Akka.NET 1.547 release. And, oh, cool. Let's see. So one thing we've done here is we've finally gotten around to adding async overloads to the multi-node test kit. This should help make them much less racy on low-powered VMs like the type that Azure DevOps and GitHub Actions use. So we've got this sort of built in here. So Gregorius and I have both been working on this. Let's see. Gregorius, do you have any more additional commits you expect on here, or are you still kind of working on this?
I'm still working on it.
Okay, no problem. But this is one that we're planning on. We're planning on getting this merged. We're also planning on getting this one merged as well, which was an issue a user reported where we basically weren't. We were essentially wrapping an operation canceled exception inside another aggregate exception. And this was just kind of a quirk with how we handled cancellation tokens. But that's been fixed. The real one I'm excited about, because I've had a chance to test this as of yesterday inside the Phobos test suite, is this guy right here. So we do not run the Akka.NET test suite with any sort of parallelism enabled, other than we basically will run each workload. So we have a workload for like .NET Framework and .NET Core, and then one for Windows and one for Linux. We basically take that matrix of all the different combinations of things we need to test, and we spread it out over separate jobs on Azure DevOps. So each job gets its own virtual machine. That's how we tend to parallelize stuff. But because the Akka.NET test suite has historically been quite racy, lots of race conditions, and part of that is because a lot of the things we're testing are very timing sensitive, especially our Akka stream stages. We basically do not really enable much in the way of parallelism. The Phobos test suite, so Phobos is our commercial product that we referred to earlier, is the raciest of all the test suites we have to manage for one simple reason, which is that you have Akka.NET, which is already an asynchronous background processing sort of framework. And we add to that Open Telemetry, which is a asynchronous background processing telemetry for Akka.NET. So you basically get like two different layers of asynchronous racy stuff that's somewhat non-deterministic. We were able to get the Phobos test suite which we run in parallel. We run Phobos's test suite in parallel by assembly. So we'll run all the test assemblies at once. We were able to get the failure rate of that test suite down to 0 with this change. So this is a really big improvement in terms of like getting Azure DevOps and GitHub Actions to not report as many startup failures with tests. This is a really big deal. So I'm looking forward to seeing how well this works. Also, getting this fix incorporated into Akka hosting should help reduce another set of failures there. So this is all looking really good, all this stuff. And then finally, last thing I kind of wanted to touch on is Akka.NET 1.6. Now, we have not done a huge amount of work on that in a couple of months. Basically, what we're planning on doing is once 1.547 ships, we are going to try to flip the development branch over to 1.6, meaning that all of the changes going forward are going to be scaled to the goals of 1.6. So, for instance, we are very likely going to be changing our .NET framework support on there. That would be one big change we're going to do. Gregorius and I were talking this morning about inlining Akka hosting into the main repository, so it's easier and faster for us to get updates to it. We were also talking about doing things like enabling nullability and also wrapping up AOT for the core library. These are all things we think we can do in a relatively short period of time, like maybe I don't know, 6 weeks or so. Well, actually, enabling nullability for the entire project might take longer than that, but the other things should be more straightforward. So we're planning on basically trying to really move some momentum forward on this and see what we can get done in the short run here. So Gregorius, that's all I've got as far as our big ticket items go. Is there anything else that we need to add today?
No, I think that's about it.
All right. Well, everyone, thank you very much for attending today. We really appreciate it. I know that it's still summer, so people are out on holiday or doing other things. But when you come back to the office in September, we're going to have a lot more good stuff for you. So in the meantime, don't forget to sign up for the Akka.NET Discord. Keep coding and keep letting us know if there's things we can do to make your experience with Akka.NET even better. On that note, thank you for your time. We'll catch you next month.